We're going to draw the Lewis structure and determine the VSEPR geometry for B and C. We just did hydrogen sulfide. All right, let's start with B, also known as phosphine, and count the number of valence electrons. Phosphorus is in group 15, so it contributes 5 valence electrons. Hydrogens, there are 3 of them, each contributing 1. It gives you a total of 8 valence electrons. Hydrogen never goes in the center, so we'll put phosphorus in the center. We'll surround it by surrounded by 3 hydrogens. We need to connect these atoms in the molecule. That's going to require 3 bonding pairs. Each bonding pair is 2 shared electrons, so we are down to 2 valence electrons. The hydrogens are good, so we're going to put the remaining 2 on the phosphorus, giving that the octet. So let's take a look at the formal charges. Is going to be 0 on all of them. Formal charge is a way to determine the charge of each atom in the molecule, and that is the number of valence electrons in its neutral atom minus the number of dots, or the non-bonding electrons, minus the number of dashes, which represent half the bonding electrons. So you can do it for phosphorus and the hydrogen. They're all going to be 0. Just do it once. So the phosphorus has 5 valence electrons minus the 2 dots minus the 3 dashes. 5 minus 2 minus 3 is 0. So you want a formal charge close to 0 as possible on a neutral molecule like this. All right, there is what else? VSEPR. So around the central phosphorus, there's 1, 2, 3, 4 regions of electron density. So the parent geometry is going to be tetrahedral, but there's one lone pair. That means 3 of the 4 are bonded to other atoms, but 1 is not. So that's going to be trigonal pyramidal. Over here, you have 4 electron regions. 1 of them is not bonded, so that gives you a trigonal pyramidal. Let's draw that. This one is coming out at you, and this one is kind of going back. And you got a lone pair there. So the bond angles here, because the lone pairs repel the bonding pairs a little more, the bond angles are going to be slightly less than 109 degrees. Probably close to 107. All right, let's move on to the last one's going to be a little simpler. Let's go with this one here. All right, so you got 1 chlorine, 1 fluorine. They're both halogens, so they're both going to contribute 7 valence electrons for a total of 14. There's no central atom, so you can just connect them using a bonding pair. That's going to bring us down to 12, and put 6 on each to achieve the octet. There's the formal charges are 0 on this, and then that shape is just linear, 180 degrees.